This is a follow-up. Yesterday, I was charging this old phone and noticing it was increasing at a linear rate, the percentage charge. So then I made a video about it. But then I thought, well, I've got this other old phone that I want to charge up. And here it is. It was charging really slowly. So I thought I would make a video about that one, and you could compare them if you watch both videos. So I can go to Desmos.com and go to the graphing calculator, and I'll make a table. I described how to do these things in the other video, so I won't describe every step of the way. But I've got my data here. It's too small for you to see. My bad. This phone started at 15%. So at time zero, the charge was 15%. After 15 minutes, the charge was 20%. After 35 minutes, the charge was 26%. After 50 minutes, the charge was 31%. I'm going to keep going, but I'm going to change the scale here so we can see these points. I went up to 130 minutes, so I'm going to go even farther than that. I'm going to go up to, let's say, 200. And then, so the X is the time in minutes, the Y is the percent. So I'll make this go above 100%. I'm going to put some extra space down below. Maybe the closed captions won't block the X-axis here. So we've got these 4 points. Then I got distracted for an hour. I was in a Zoom meeting, and so the next time that I checked was 115 minutes, and the charge was 52%. Then at 130 minutes, the charge was 57%. So I can make a regression line for these data points. Y1 tilde AX1 plus B. And you can see this has a very strong positive correlation. R squared is 0.9999. R says it's 1. It must be 0.99999, something like that. Something that when you get to the 5th decimal place, it rounds it up, and it just rounded it up to 1. But we know it can't be exactly 1 based on the R squared here. What do we have here? We have a slope of 0.322 roughly, and a y-intercept really close to 15. So this does fit my points really closely here. So the slope here of 0.322 is telling us the increase in percent per minute. So the charge is increasing at 0.3% per minute. So that's roughly 3% every 10 minutes. So how long would it take this thing to charge up to 100%? Isn't that the question that we're always asking? So I can type the horizontal line, y equals 100, and of course, it's way off in the future there. So I will change the X scale. Will 300 do it? Yes. Okay. 300 minutes, that's 5 hours. And we can see at this intersection point, it says it'll be charged after about 264 minutes. What is that? 240 minutes is 4 hours. So this is about 4 hours and 20 minutes. Okay, so there's that. But here's the thing. I started making a previous version of this video, and I accidentally unplugged the phone when I was trying to show it to you, and then I plugged it back in. And then I checked a new data point. After 145 minutes, the charge was 70%. What this means, I think, is that it wasn't plugged in tightly enough. Oh no, check it out. The rate of charging is really it has really increased in those last 15 minutes there. So I probably should not have this in the same table. I should make a new table. Let's try that. New table. Okay, I've got all these things going on here. So I'll start with 145 minutes, 70%. And well, let's see what time it is now. It's well, it's going to be 7 minutes after that, so I'll go 152 here, and then in a moment I'll check the charge here. I have to stall for 7 seconds. 3, 2, 1. The charge is 76%. I can't quite hold it up high enough for you to see on the camera. So I guess I should start with this one as well. Well, it depends on when I unplugged it. Anyway, I'll make a regression line for y2 and x2. y2 tilde ax2 plus b. You can see that it does pass really close to this other data point. So now the slope, if I can make that visible, the slope is, well, that's the decimal for 6/7, isn't it? So it charged 6% in 7 minutes. Yeah, that's obvious if you look at the numbers here. From 145 to 152, that's 7 minutes, and the percentage increased by 6%. So yeah, your slope there, based on this limited data, is 6/7. So increasing about 0.857% per minute. The y-intercept doesn't make sense here. There's no way the phone would have been at negative 54.2857%. But if we could find where y equaled 15, we could see how much time it would have taken to, if I had plugged it in the right way from the beginning. So isn't this amazing? This is amazing. So I will put in the line y equals 15. And this is really where this should start, is that I would have saved 81 minutes charging this if I had plugged it in tightly the first time. So this would really be our starting point here. And so if I were going to write an equation in point slope form for my new line, I would have to see those values again, 80.833 and 15. Okay, so I would have y equals the slope that I know is 6/7, because I'm good like that, parentheses x minus 80.833. That's 80 and 5/6, wouldn't you say? Well, I'll just do the decimal. I don't know how to type a mixed number into this. Desmos. There. So I'm using some fraction, some decimal, but it's close enough here. So there, you can see that that would be a good starting point for this new line. It doesn't make sense to go back in the past before minute 81. So if I had been charging it right away, I would have saved 81 minutes there. So I'm interested to see how long it should take to charge up. Wow. Well, again, just based on two numbers, I happen to get some numbers that look really nice and precise. But according to this, it should take about 3 hours to charge. Nope, it should take only 100 minutes to charge, because I'm starting from minute 80 or 81 and ending at minute 180. So that is about 99 minutes. Well, that's really close to 1% per minute. Isn't that wild? That's pretty wild. Hey, it's almost been 4 minutes since I took the last reading. So let's just do one more, and then we'll probably wrap this up. 3, 2, 1. 79%. So what's the time here? 1:56 now. 79. Turn this off. So that changed the slope a little bit. It was 0.857. Now it's 0.822. So it may have slowed down a little bit, but really, I think it's just because basing something on just 2 points, you're really dependent on what those 2 points are. Basing something on 3 points, it'll be a little bit different, but you can see that it is still aiming pretty much in the same direction. And now the prediction is that it would take about 1 minute longer for it to charge. So I'm not too worried about that. And and down here, instead of starting at minute 81, I would have had to start at minute 78. So it's, I don't know, maybe it's saying it would take a total of 1 + 3, 4 minutes longer to charge. Who knows? Who knows? Well, I hope you enjoyed that. And I probably won't remember to check in after 180 minutes and see whether this thing charges, but oh, maybe I will. I'll save this page. Okay, thanks for watching. Goodbye.